Mid-air collisions, while rare, can have catastrophic consequences. With the increasing number of aircraft in the sky, the need for effective collision avoidance systems has never been more critical. ACAS primarily includes the Traffic Alert and Collision Avoidance System, or TCAS. Developed in the late 1980s, TCAS was designed to monitor the airspace around an aircraft, helping pilots detect and avoid potential collisions. TCAS operates by using transponder signals from other aircraft. It continuously monitors the altitude and position of nearby planes, assessing potential collision threats in real time. When TCAS identifies a potential threat, it categorizes these alerts into three main levels. A traffic advisory, or TA, is a preliminary warning, prompting pilots to be vigilant but not requiring immediate action. A resolution advisory, or RA, provides specific instructions, such as whether to climb or descend to avoid a collision. Lastly, visual alerts display critical information on cockpit screens, enabling pilots to quickly assess the situation. TCAS acts as a second set of eyes for pilots working independently from air traffic control. It's crucial for enhancing safety, especially in busy airspaces. To truly appreciate the significance of ACAS, we need to understand its history. Before TCAS was implemented, mid-air collisions were a significant concern in aviation. The need for better systems became increasingly clear as air traffic grew. One tragic incident that underscored the need for ACAS was the 2002 Überlingen mid-air collision. This disaster highlighted the vulnerabilities in air traffic management and prompted significant advancements in collision avoidance technologies. Since the introduction of TCAS, the rates of mid-air collisions have dramatically decreased. Research shows that the system has prevented numerous potential accidents, effectively saving lives. TCAS doesn't just alert pilots, it also communicates vital information with the aircraft's avionics systems. When a threat is detected, TCAS provides data such as the relative altitude and distance of the intruding aircraft, allowing pilots to make quick, informed decisions. Pilots receive both visual and auditory alerts. The system alerts them to the presence of nearby aircraft and guides them on the safest course of action to avoid a collision. Training is a crucial part of preparing pilots for potential collision scenarios. In flight simulators, they practice using TCAS, learning to interpret alerts and respond effectively. As technology continues to evolve, so will ACAS. Future systems are expected to integrate artificial intelligence and satellite-based tracking, which will enhance situational awareness even further. Imagine a future where aircraft can communicate seamlessly with one another and with air traffic control, providing real-time updates on flight paths and significantly improving overall airspace safety. The rise of new aircraft types, including unmanned aerial vehicles or drones, increases the demand for robust collision avoidance systems. The integration of ACAS technology across all airspace users is essential for future safety. Industry leaders and regulatory bodies continuously work to improve these systems. Innovations like cooperative surveillance, where aircraft share their position data with each other, are being developed to enhance safety further. Let's take a closer look at how TCAS works. At its core, TCAS consists of a processor, antennas, and a display system. The processor analyzes data from the transponders of nearby aircraft, while antennas send and receive signals. The system uses a complex algorithm to determine the risk of collision and generates alerts based on the proximity and relative altitude of other aircraft. Here, you can see TCAS in action. As an aircraft approaches, the system detects it and issues a traffic advisory, prompting the pilots to remain alert. If the situation worsens, a resolution advisory will guide them to take evasive action. Regulatory bodies such as the International Civil Aviation Organization, ICAO, have set standards for the implementation of TCAS in commercial aircraft. These regulations ensure that all aircraft operating in controlled airspace are equipped with compatible collision avoidance systems. Standardization across the industry is vital. It ensures that all pilots and aircraft can operate under the same safety protocols, significantly reducing the risk of collisions. While ACAS has made significant strides in enhancing flight safety, challenges remain. One major concern is the effectiveness of TCAS in complex environments, such as busy airports or during adverse weather conditions. In these situations, the system may face limitations in accurately predicting aircraft trajectories, which highlights the need for continuous improvement and innovation in collision avoidance technology. Looking ahead, several exciting technologies are on the horizon. Concepts like automatic dependent surveillance broadcast, ADS-B, allow aircraft to broadcast their position, enhancing situational awareness for both pilots and air traffic controllers. ADS-B provides real-time data about an aircraft's location, speed, and direction. When combined with TCAS, it can further reduce the risk of mid-air collisions by providing more comprehensive information. Collaborations between technology companies and aviation experts are essential for developing next-generation collision avoidance systems. The integration of machine learning and predictive analytics could revolutionize how we approach flight safety. Public awareness and understanding of ACAS and its importance in aviation safety are also crucial. Educating passengers about the technologies that protect them can build confidence in air travel. While most travelers may not think about these systems, knowing that advanced technologies work tirelessly to ensure their safety can make flying a more reassuring experience. Thank you for joining us on this comprehensive journey into aircraft collision avoidance systems. We hope you've gained valuable insights into how these technologies make air travel safer for everyone.